Welcome everyone to the week 8 tutorial session. I am Rati Ludhani, pursuing PhD at Department of Mathematics, IIT Bombay. I am a PMRF fellow here. Today we'll discuss week 8 sample questions related to lectures of week 8. Okay, let's begin. Let M be a matrix associated to the network below with all edges having weight 1. Okay, so what is given here? Okay. So firstly, where it is related to what? So can we apply LGV lemma or not? This is the question. So basically, what is the LGV lemma? Okay. Can you recall? What is LGV lemma? So, do you want to say? Okay, so what is LGV lemma? It is really okay. There are some requirements for the lemma. It's like necessary conditions, and then we can do that. So I'll go to the lecture notes, and that will be great, I guess. So yeah. So let S be A1 AN, B1 BN, P as above. So what does above mean? So A1 to AN, you have some. Okay, I'll change the color. Or maybe red. Yeah. So you have A1 to AN and B1 to BN. And now what you are having? So S is what? These AIs are a subset of AIs, and BIs are a subset of belongs to S. And now you can basically what you are talking about, the paths from A1 to B1, A1 to B2, A1 to B3, and so on. So it's like if you could have some path like this, and there could be nodes between, and then you will get something like this, maybe this. Okay, some paths are there. Now and V is what? V is the weight of this path. Like, what will be the weight of this path? So it will be given there. So weight of this path will be the product of all the paths, all the subsequent paths. Okay, and yeah, that is V, that is weight. S is this, and so these are the notations. Now and this should satisfy crossing condition. So what is crossing condition? It says again, the crossing condition says if you have something AI and AJ where I is less than J, so you'll keep it in order. So if AI is less than, so there is an ordering between this. Okay, and we are assuming these values are in an order. So it's like AI is if I is less than J, and the other side I dash is less than J dash, then path from AI to BJ and path from AJ to BI dash, sorry, AI to BJ dash and AJ to BI dash should cross somewhere. So if you pick any path between AI to BJ dash and any path between AJ to BI dash, then they should cross. That is the requirement. So this is exactly this. Crossing means there is some point between in the path that should be same. Like if you number it like this, S0. So for example, if you start by S0, S1, S2, S3, and here if you start with T0, T1, T2, and or maybe T2, T3, and let's say T4. So S4 and S3 and T4 are same. So at some point it should cross. That is the requirement. So if that satisfy the crossing condition, this should be there. And then let M is equal to Mij n cross n, where Mij is equal to the summation over the weights of the path. So Mij, the matrix, the entries of matrix is like this is M11, and M11 is what? All the sum of all the weights of paths from A1 to A1 to B1. So it's for every Mij you can have like this. Then determinant of M, so M is this with each entry as defined. Then determinant of M is equal to the summation over pairwise non-crossing paths. So this is you'll take the product V omega I, where omega I is a path from AI to BI, and each omega 1, omega 2, omega 3, and whatever path you are considering for different i's, they should be pairwise non-crossing. Is that clear? I'm connected to the internet, right?
Yes, sir.
Yeah, okay. Yeah, just say yes or no. It will be helpful for me because I am not sure if I'm connected. Okay, great. Thank you. So yeah, this is the lemma. So okay, let's see what do we have now. So this is, yeah, as in class, as in lectures, or maybe it's fine. Okay, now what has been asked, so there is one more thing here, which is set somewhere. Okay. One second. Okay, so basically what I am saying, so let's see the B part first. Okay, so what does B part say? uh, can we apply LGV lemma or not? That is the question. So regarding B, what can you say? You have something A1, A2, A3, B1, B2, B3. So these are the paths given. So for example, a path, if you want to pick, so from A1 to B1, you can so these are directed graph. This is a directed graph. So there is one, this is the one you can pick A1 to some point. This is some like some point, let's say S1. So A1 to S1 and S1 to B1. So this is one path. The other path you can take, you can go like this, and you can go like this. And one more thing, with all edges having weight 1, so all the edges have weight 1. And so yeah, this you can go like this. Just look at the arrows, and then this, but not this. So this cannot be considered because you cannot come back. So this is the only path, the one I showed in first time. Sorry. Yeah, you just go like this only. So this is the only path from A1 to B1. Can you tell me a path? So I'll just show you a path from A1 to B2. So you can go like this, you can go like this, and you can go like this. So this is one path, A1, S1, B1, B2. So just look at the arrows if you can reach B1 or not. Now A1, you can also go like this. So A1 to B2, you can get at least 2. So okay, I can change colors. So this is one. Okay, the other one is this, and then this. Okay, so you can go on like this. Now and do you have any other path? You cannot have it because you cannot go like this, because this is the other side arrow. You will go again like this, and then you can go this and this you have considered, this and this you have considered, this and this you have considered. Now A2 to this, if you go, and then you reach to B3, but you cannot come back to B2. So to B2, A1 to B2, you have two paths. Is that clear? Like how we are looking at L.
Yes, ma'am.
Okay, great. I'll try to number it, or maybe name it. So for example, I'll just name it to be S1, and let's say S2 and S3. Okay. Yeah, all other are already numbered. Okay, so now what are the requirements of LGV lemma? So can you tell me if you can apply LGV lemma or not? So first look at the hypothesis. So here is the hypothesis. Yeah, this one, as you have seen. So can you tell me if you can apply LGV lemma or not to B?
Ma'am, isn't one condition to apply LGV lemma is that the graph needs to be acyclic?
Yeah, so yeah, you can check that. Is this a cyclic or not? Is this a cyclic or not? So basically, there should be no cycles. So no cycles
So
means.
Here we find path. So path is
Sorry.
acyclic. Here we find path. So path is only three type and no acyclic.
Yeah, there is no cycle, right?
there is no cycle.
Yeah. So cycle is like this. So as you have mentioned already, a has a cycle. So if you see that, can you tell me which is the cycle in A?
A1 to A2, A2 to B2, B2 to B1, B1 to A1.
Exactly. So this is a cycle, and LGV lemma does not work with the yeah, cyclic graph. So if you have something like that, there will be a problem. Okay. So yeah. So A will fail because there is a cycle. LGV lemma does not hold. Yeah. Because the network is cyclic, or maybe there's a part which is cyclic, a part. Okay, great. So in this B part, there is nothing like that. There is no cycle. So what can go wrong, or is there something which we also think about? So there is one more condition. If you see here, there's a crossing condition. Okay, we should check if there's this.
We go to A1 to B1 answer.
Yeah, so you have to consider, you have to check, basically every time you should check. So in this, for example, let's check if that is true or not. So you will consider something I is less than j and I dash is less than j dash. Okay, you'll consider something like that. Here n is 3. I'll just keep it 3. So you consider some I and j and I dash and j dash and see the path between these I and j dash and I dash, j to I dash. So let's see what do we have. So can you pick something?
A1 to B2, J equal to 2, A1 to B2 and A2 to B2.
A1 to B2. Okay, A1 to B2 and so I and j, I am assuming you okay, which one you are considering? So let's say I you are taking 1 and j dash you are taking 2. So that means the only possibility for I dash is B1, and here you can take anything like maybe what I want to say, yeah, this one. So you take so I'm saying I dash you can take it to be 1 now. Sorry. Okay, there's nothing possible here. So for example, if you take A1 and B2, then what should you have? What the other thing you can take? I'm just looking at. So basically, what we are talking about, you have A1, A2, A3, and you have B1, B2, B3. and you are saying you are going from A1 to B2 and then A2 to B1. This should not cross. You are saying like that, right? So for example, if you are taking A1 to B2 and A2 to B1, yeah. So let's see if there is a there's something like that or not. So you have to consider the paths. Okay. So A1 to S1 and S1 to B1. Okay. There is one path from A1 to B1. Is there any other path you can take? There is only one, right?
Yes.
Yeah. Uh, is there some noise coming from someone's? Yeah, that will be great. Yeah, you can speak whenever you want to, but then you can mute yourself. Thank you. Yeah, so one path you can take A1 to S1 and S1 to B1. Okay. Sorry, not B1. We want to go to B2. So you can take A1 to S1 and S1 to B1 and B1 to B2. So there is one path, and then 1 second. We'll take vertical. Yeah. So you consider this A1 to S1, B1 and B2. So I am considering for this, and from now you have to check whether if you take from A2 to B1 will something cross or not. So A2 to B1, can you go firstly? Is there any possibility to go from A2 to B1? No, so we cannot consider this condition because what it says, you consider these two, and then there should be a path, like to check there should be for hypothesis, like, or maybe like the requirement is there should, if there is a path, then it should be crossing. Okay, but if there is no path, then nothing to check for this one. Now let's see with
Also, ma'am,
yeah. Yeah.
A2 to B1 should be like, even if there were a path, should we consider A2 to B1 because I dash is strictly less than J dash, so I thought 2 is greater than 1, so.
Yeah, no. So I is so what I considered, I is 1 and J is 2, and I dash is 1 and J dash is 2. So now what you are taking, so you are taking
Yeah,
I
so,
to J dash
A2 to B1, yeah.
and I dash to J. So if you check, so what is required, it's like this. So AI to BJ dash and AJ to BI dash.
Okay. Yeah.
Right? So from this to this, I to J dash and J to I dash. Okay. So now let's see, and you are going from A to B only. So there is nothing like B to A. So we are not talking about B to A. It's like A to B. Now the first thing you take AI to A BJ dash, and other you take AJ to AI dash. So for example, A2 to B1 there is no path. So let's see if we can do something else. So we should, yeah.
Can I do A3 to
Yeah.
B1?
Exactly. So let's try, because that is the only other possibility we should check. So yeah, exactly. You take so for example, you take 3 and 2. So what I mean by 3 and 2, you take 2 less than 3 less than or equal to 3. I'm writing like this so that it means this is I, this is J. Okay. And other you take again 2 3. Okay, now what you need to check, the path between these. So what does that mean? You take A2 to B3 and A3 to B2. You check these two now. So let's see what do we have when you take A2 to B3. So what is the path you can take? A2 to B3, A2 to B2 and B3. There is this one path. And now there is B2 here, right? The ending point should be from B and the starting should be from A. Okay. So firstly, if it is coming with B2, definitely we are not going to check that, because B2 is already a common point now, right? So we should check where B2 will not appear or A3 will not appear. Okay. So for example, this path, no need to check. Other path, let's see, A2 to, for example, you can go via this A2 to S3 and then B3, right? This path A2 to B3A. So
Yes.
I'm going like this. Okay. Now, yeah, this is something which we should check. Okay. So now let's see A3 to B2. So you have, for example, A3 is this. Okay. So A3 to B2, if you go like this, and then you will reach at B3 only. So if you go like this, then definitely you are reaching to just B3. You cannot go back to B2. So this could not be the path. Now what you can do, you go like this. Okay. If you come to this, there is nothing to check, because again A2 is a common point, and we started in the first one, we started with A2, so there is already a crossing. So what other path we should check? You go like this, and then you go like this, you go like this, and then this and this. So what I did, A3 to S2 to A1 to S1 to B1 to B2. So what is this? This one, this one, this one, this one, and then this. Okay. So is there any crossing? So you have two paths to check. This one, A2 to B3 and A3 to B2. This one. Is there any crossing? So this is the graph. So basically what you are doing, you are coming from here. Okay, and the other is this. So definitely there is no crossing. So this is the other is this. So if you see red marks and green marks, there cannot be a crossing, right?
Yeah.
So this we cannot apply LGV lemma here. So LGV lemma cannot be applied because there is no crossing between let's say path 1 between A2 to B2 B3 with path 1 and A3 to B2 with path 2. So there exists some path for which there is no crossing. So we cannot apply LGB lemma. So whenever you have something like that, you should check it first that whether we can apply or not. So there could be there are mostly these two requirements which we need. There should be no cycle, and there should be no like no non-crossing thing. So if this is there, then there should be a crossing. Okay, is that clear? Okay, great.
Yes, ma'am.
Yeah. Okay, let's move to the next question then. Consider the path matrix M. So you have this path matrix M, Mij, I comma j is equal to 1 to 4. You have this. So basically you have this matrix, and yeah, so it's like M11, M12. So you need these elements. I no need to write it, but okay. Yeah, so this is this. So now what you need to do, corresponding to this following graph, consider this matrix M and calculate all the entries of M and determinant of M. So you need to use LGV lemma to find out the determinant. So let's see. Okay. So firstly, to be honest, if you just want to find out determinant, then it is enough. Like you don't need to find out all the entries of M. If you check both the properties, like there is no cycle, and the other thing, like there is a crossing always whenever I is less than j and I dash is less than j dash, then there should be a crossing between ai and aj dash, and aj to ai dash, sorry, b, so yeah, I is less than j and I dash is less than j dash, so there should be a crossing between ai to bj dash and aj to bi dash. So if you just check these two properties, is cyclic and this crossing thing, then you can directly apply LGV lemma. So, and you know that there will be some matrix. So if you just need to find out determinant, you can just check for only this. So for example, what we need only okay, I'll write it down. So what is the determinant? If you remember, determinant is always summation omega. So yeah, exactly. I'll write it down. So you have this is a path,
WI
yeah,
from AI to BA.
yeah, exactly. And pairwise non-crossing. So what we are saying, this should be, so if you consider any path from ai to bi and aj to bj, so ai to bi and aj to bj, if you consider these paths, there should be no crossing. Okay, there should be no crossing between them. So you are just considering only those omega 1 to omega n, such that there is no pairwise crossing between them. Okay, is that clear? Okay, so you will consider the weight of wi. Very good. Yeah. So this is the determinant you need. Yeah. Okay, so let's see, what do we, so what I mean to say, you don't need to find out all the mijs to find out the determinant. If you just verify that this you can apply LGB lemma, then you can just calculate the determinant and you will be done. But explicitly it is asked that what are the entries of M, so we'll do that. Okay, so let's see, yeah, so this is the path, so I'll just copy this. This is the network. Yeah. Okay. So what do we have now? Now what you need? You need M11. So M11 is what? So the matrix entries you need. So what is M11? You need to find out all the paths. So this is what? This is the sorry, yeah, the requirement is M11 should be what? The summation of yeah, tell me. So this is the summation of paths, right? So V of sorry, yeah, A1, yeah, A1 to B1, and you write W, yeah, exactly. So you do it with the summation. And what is VW? VW is the what is VW? VW is the product of the subsequent paths. Okay. Yeah. Okay. So let's calculate it. Give 1 second. Just need to check one thing. Okay. Great. Yeah, so let's calculate. Okay, I'll number it again. So I'll say this is S1 and S2. Okay, so that you can tell me. So path from A1 to B1, and it is given that all the paths have same weight, which is 1. Okay, so each edge has weight 1. So we don't, so in the product you just take 1 into 1 into 1. So in the summation you are taking 1. Okay, but how many ones are there, that is the question. A1 to B1, and so how many times you will add 1, that is the question. So how many paths are there, that is actually you need, right? So tell me how many paths you are going to get for A1 to B1. So let's count it down. So you have, can you tell me?
Two parts.
Yeah, two paths actually. One is what? A1 to S1 to B1.
S1.
Yeah, exactly. And you have A1, A2, and B1. So there are just two paths. So the entry is 2, right? What is M12? Again, you will consider all the paths which are from A1 to B2. And now again, the point is every path has weight 1. So the product will be 1. So you are just calculating how many paths are there because you are just adding 1. Okay? This is the summand of ones. So let's see what do we have for A1 to, right. So A1 to B1. Sorry, A1 to B2. Okay, A1 to B2, can you tell me?
A1 to A2, A2 to A3, A3 to B2.
Exactly. And yeah, this is one. Other?
A1 to S1, S1 to B1, B1 to B2.
Okay. And do you think there is more?
A1 to A2, A2 to B1, B1 to B2.
Yeah, exactly. So just remember you are you are counting all or not. That is important. So A1 to yeah, I'll tell you the pattern in next question. That will be better. Here also you can get it, but like you can count here easily. So that's okay. Okay. Now again, let's see what is M13. So again, I'll do that. So so at each step actually you are getting more, one extra. Why? Because you can go like you now again what you can do from this, and now next you can go like this. Again you can go like this, or you can go like this, like so at for each step, like from A1 to B3, if you go A1 to B2 and then you go A1 to B3, you are getting one extra path. Because what exactly is that you can yeah, because there are three lines you are getting, so one extra line you are getting downwards. So that is the benefit. So here you will get 4, and similarly when you do a M14, you'll get A1, yeah, 5. Okay, so M21, yeah.
3.
M21 is 3, is it? So M21 is I'll remove these.
1.
So you have this, yeah.
No, 2 is.
Yeah, I agree. Malakshmi, can you mute yourself? Whenever I ask, you can unmute and say, and then you can mute again.
Okay.
Yeah, that will be great because there is noise here. Uh, Thank you. So M21. So yeah. So M21 is 2 to 1. So you have this option only. Is there anything else? No, no. So A2 to B1, there is only one path, because you can go from here, but you cannot come back. If you go downwards, then there is no path from here to here. So there is just one path. So you have A2 to B1, that is exactly 1. And now M22. So A2 to B2, you'll go from here to here, and then here to here. So there are two paths. Okay, similarly A23, you'll get. So basically what is happening, at each step you are getting one extra. So you can do that as I did in earlier. But whenever you are going, whenever the row number is going down, like increasing, so basically what you are getting, 4, sorry, 2 3 4 5, and then you are getting 1 2 3 4. And then now let's see, do you have any path from A3 to B1? Is there any path between A3 to B1?
No.
No path. So this is exactly 0. Very good. And A3 to B2, you have just one path. And now again you will get one extra. So you get something like that. And again A4 to B1, there is no path because there is no way to go behind. So it's like this is 0, this is 0, and you get 1 and 2. So this is kind of a pattern you are getting. And yeah, I keep it as an exercise. Verify that obviously there is no cycle because there is no cyclic arrows you can get here. Verify that this is uh, for every I less than j less than, so n is your 4, 1 and 1 less than I dash, sorry, j dash. There is a crossing for every path. Okay, I am not keeping, or I'll just write verify that the non-crossing, sorry, verify that this satisfies crossing condition. Okay, actually you can easily see. Just check if there is a path which can cross, there will always be a crossing because yeah, you can check it. Okay, great. So yeah, this is your this is the matrix. So this is M. As I said, there is no particular requirement to calculate M, like to get the entries of M, but yeah, as it is explicitly asked, I calculated it. Now let's see what is the determinant. Determinant is again this is summation. You take all the omega i's. Yeah, this is omega I is ai to bi, and there is, this is non-crossing, pairwise non-crossing. And here you have a product, product weight of omega I is from 1 to n. So now let's see how many paths are there with non-crossing requirements. So you are talking about, you will consider A1 to B1, A2 to B2, A3 to B3. So you are actually talking about the diagonal entries, not entries. It's like you are looking at diagonal, you are looking at the paths corresponding to diagonal basically. Okay, so you want to check now whatever path you consider here, they should not cross. You have to consider all the paths which satisfy this condition. And similarly there is I don't need to go till 5, it is just 4. And similarly, this should not happen with this should not happen with this. So all of these should be non-crossing. Okay, so whatever path you consider for A1 to B1, it should not cross with the path which you are considering for A2 to B2, and it should not cross with the path with A3 to B3, like for pairwise non-crossing. Okay, now let's see what do you have. So A1 to B1. So firstly, now when you want, it should not cross with A2 to B2. So you should, so there is from A1 to B1, how many paths are there? You have this or this, right? Now as you can see, A1 is in this path. In this path, A1 is involving A2, right? Now if A1 is involving A2, that means this path you cannot consider, because when you consider A2 to B2, then A2 is already appearing, so it will be a crossing. So it should not touch the points of the starting and end points. So it is clear that you cannot take this path, A1, A2, B1. You cannot take this path. So I'll just consider this one. Okay, so for A1 to B1, we have considered A1, S1, B1, because there is no crossing with A2 to B2. For instance, you should check with A3 to B3, but those are very far, so you will know there is no requirement right now. Now let's see with A2 to B2. Now you can go with this path. Can you go with this path? So how many paths are there? Again, you have A2 to B2, there is this path, and the other path is this to this, right? There are only two paths. Can you consider any of them? Can you consider any of them? For example, can you consider A2, B1, B2?
No, because this is crossing with the previous one, A1, S1, B1.
Yeah, exactly. So if you consider, yeah,
And the other one also, A2, A3, B2, that is taking A3 into account, which
yeah,
will cross with the other paths.
exactly. So basically, when you take A2, A3, and B2, and both of them you cannot consider. Yeah. Yeah, so both of these you cannot consider. Sorry, can you unmute yours? Sorry, mute yourself. Yeah, thank you. There is some issue with the noise. So yeah, both of these you cannot consider. So basically, you cannot consider any W2 here. So at least you cannot consider W2. There does not exist any W2. So what will happen if there is nothing there? Like there is nothing as W2, and in this product, what will you get? Sorry, yeah, you will get VW. So what is this? VW1 into VW2. You cannot consider this. So basically, you have just 0 because there is nothing as W2 here. Okay, so this is just the empty sum. Is that clear? This is 0. Determinant is 0. So yeah, as I said, there is you can just calculate the determinant by checking, by verifying this property, crossing condition, and you can check the cyclic thing, and then you can just directly calculate determinant, and this is 0. Okay.
Using this matrix also we can find determinant value.
Yeah. So basically, LGV lemma helps you to calculate it to calculate the big determinants easily. So yeah, this helps in that case also. So you can calculate it, but as I said, you don't need. So if you see what I did, I took the significant amount of time to calculate the entries of M rather than determinant. Determinant could be calculated very easily because you can see, you just see the graph, you check the non-crossing things, and then you are done. Okay, and but to calculate these MIJs, it took some time. So this is helpful in that case also. But yeah, if you have very big matrices, then it is very hard to calculate, and you can use this LGV lemma if it helps. Okay, yeah. Okay, let's move to the next question then. Let M be a matrix associated to the network below. Now this is your network, and again with all edges having weight 1, find M11, M12, M24 and determinant of M. So we need to calculate these MIJs. So let's see, what do we have. So again, what you need to see, what is A1 to B1. So yeah, here you can see this is very big, at least this is somewhat big uh, compared to the previous one. So we'll try to find some formula or something. Okay, so let's see, from A1 to B1, what do you have? Yeah, okay, let's see. Okay, I'll again number it so that you can tell me. S1, S2, S3, S4, S5. Okay, now let's see how many how many yeah, how many paths do we have from A1 to B1. So okay, can you tell me some paths at least?
A1 to S1 to B1.
Yeah.
A1 to A2 to yeah, A1 to A2 to S2 to B2 to B1,
Hmm.
and
uh
other stuff, A1 to A2 to A3,
yeah.
then to S2 to
Mm-hmm.
B3 to B2 to B1.
Yeah, exactly. There are many. So let's see if we can get some formula or not, because it will be hard otherwise. Okay, so what we are doing, let's see some pattern. So you have A1, A2, A3, A4, A5. So you are going from here to here. So what is allowed? So you can go on right, you can go downward. So these are all positive. So positive means weight 1 is there, otherwise it is just 0. So you can go like this on the right and then down, and then you can go to the left. Okay, so these are the main directions you are having with the with positive weight. Okay, so for example, what I'm looking at, what I'm thinking, so you consider this, you go with the full a edge. So when you go A1 to A5, then there is no option to have more than this. Like more than this means, if you go A1 to A5, then there is only one option to go back to B1. So when you go like this, then you have just this option, the downward part, A5 to S5 and S5 to B5. So there is no option to go like this, right? At this location you have just the right side. Okay, so like this, and then when you reach at B5, then only option you have to go straight to B1. There is no other option. So when you fix A1 to A5, then there is only one path you have. So A1 to A5 means I am going from A1 to A5. Okay, now let's see the next one. Now you so when you fix A1 to A5, so what is the we are trying to find a pattern so that we can get some formula. Okay, so pattern is always like, you fix something and then see how many are there after that or something like that. So for example, I considered A1 to A5. So this is this, then there is only one path after that to. So what I'm looking at A1 to B1 only. Okay, I'll just erase this and I'll keep here. And I'll change the color of this, A1 to B1. So I'm looking at A1 to B1. Now first you did this, now second, let's see, count is 1. Okay, now you take A1, A2, A3 and A4. Now you stop at A4. You are not going to A5. Now you have already considered A5 part. So what you are doing, you go there. So if you eliminate the option to go to A5, then the only option is to go downward from A4 to. So now if you stop at A4, then you have only one option, which is A4 to A5. Sorry, A4 to S5. So what you are doing, I am combining this. So you are going A4 to S4. So you are stopping at A4. Now the option of A5 we have already considered. So other option is you consider going to S4. Now at S4, how many paths are there? So how many paths you can consider? You can go like this. Okay, so with green I am doing right now. So going to S4 to, so you have S4 to B1, sorry, B4, B3, B2, sorry, B3, B2 and B1. there is one path. Okay, I'll write first, second, that is better. So this is first, this is second, so you have one. So this is one path. Second path is, you consider S4. You have reached at S4, so S4 is already there. Now from S4 you are looking where you can go. So you went downward and you went like this. Now what you can do, you can also go to S5, and then when you reach at S5, there is only one option: B5, B4, B1, sorry, B3, B2, and B1. Right? Is there any other option? Is there any other option?
No, ma'am.
Yeah. Okay. So with S4, exactly, with S4, this is the only option. So these are the only options. So two options are there. Now, if you look at, okay, I'll try with third also, then I'll tell you the pattern. Okay. So third is, you go with so you start with A1, A2, A3. Now you have considered with going to A4, you have already considered all the options. Now you stop at A3 and go downwards. That is, you go to S3. You go to S3. Now when you go to S3, now what are the options? You can go to, yeah, S3 to S4 to S5. Yeah, I'll write, don't worry. B2 to B1. Other is S3 to, so what I did, I went like this, this, and now what I can do, I can also go like this, and then S2 to S3 to S4, and then I'll go downwards from here only, B3, B2, and B1. What is the third one I can consider? I can consider this S3 to, so yeah, I'll go downwards directly, B3, B2, and B1. Yeah, these three we have. Yeah. Okay. Now, Mahalakshmi, right? You can yeah, mute yourself. Thank you. Because there's some noise. Okay, so you have one, two, there are three options now. So what I'm saying is the pattern. If you see what we are doing, so when we reach at A5, let's leave it there. Now when you reach at A4, you are going down. So what you are doing, you are just trying to calculate this box. So in this box, what you are having, you are having all the options in this box, like going like this or going like this. So you are going one step downwards. Okay, so this is like 1 plus, so what I'm saying, I'm claiming this is this, and okay, so I wrote K, I can actually write. So basically what is happening, okay, I'm saying the number of paths from A1 to B1 is summation K is equal to 0 to, I'll tell you what it should be. So let's see what it should be. So what we are doing, so this is 1. So the downward step is just 1, because at each step what you are doing, okay, yeah, so at each step what you are doing, you are reaching at some this kind of box, either this box or this box, right? or this box. Okay, so in all of them, what you need to do, you just need to go one step downward. In any case, like whatever path you choose, you have to go downwards one step, right? So for example, if you remember, this is like if you have something like this grid, and if you want to reach from here to here, so how many paths are there? Like for example, this, if you want to reach from this point to this point, then you need to go two steps downwards and two steps on right. So this will be 2 plus 2, choose 2, right? So like for example, if you have 3, okay, this became messy. Or for example, if I need to reach at this point, this point and this point, so there are 3 paths which there are 3 steps you need to go downwards and 2 steps to right. So you will get something 2 plus 3, choose 3, or 2 plus 3, choose 2, both are same. So these many paths you are getting. So similarly, what I am doing, I'll just do so one step I am going downwards, but at each option, like so what is exactly is important, because when you reach at this point, so for example, if you start at S4 and from S4 if you reach at B4 anyhow, then there is only one path, there is only one option. So what you are doing, you are just multiplying with this. So this is 1 into 1 into 1. So what exactly you need to consider, you need to consider all the paths from S4 to B4. That is a requirement. So that is this box. And how many paths will be there, because there is one path which you need to go sorry, there is one more thing. Okay, how shall I say? So one step you are going downwards, and then for example, at this step you are getting 1 and 1, because this is the path you need. So you are going right. mm, okay, yeah, okay. So I'm comparing with this, so that's why I'm a little bit confused. So basically what you need to choose, so one step you are going downwards. Now how many options are there for the paths? So you need to go so the box is of like 2 step so there is one more thing, when you reach at B5 you have only one option. Similarly, when you reach at B4 there is only one option. So how many paths you are going, like how many times you are going at this side, that is important. Okay, how shall I say? Okay, is that a bit clear? I am not sure, but I'll try to do that.
Yes, ma'am.
Okay.
So, for example, like if I am at say S3,
Mm-hmm.
then I have 2 boxes at my right.
Yeah.
So I have to consider all possible paths in between the 2
Yeah,
boxes.
exactly.
And like it's like that.
Mm-hmm.
How many east to y and how many north y paths I can have between the boxes. I
Yeah.
have to calculate that.
Yeah, exactly, very good. Yeah, yeah. So yes, you need to just calculate like how many times you can, so how many paths are there like this, and this you need to calculate. So if you, because the important thing is just the box what you are having, because after you reach from here to here, then there is only one way, right? So the box could be like this, the box could be just this, or the box could be just this. Or so at first step there is no box, so it's just the line, right? Yeah, it's just the line. Now at the next step you have this box. Next step means when you reach at S4. So one thing is, so for example, with S5, uh, starting at S5, or I can, yeah, write at S5. So with S5 you have just one line, and with S4 you have extra box. At S3 you
So
have,
this could be If there were like now in this picture there are like two rows of boxes, so if there were like three or four rows of boxes, then what we have to do is first come down one step to the
Yeah.
S1 or whatever, then we have to say that how big the box down below it is. Like there can be multiple rows of boxes as
Yeah,
well.
yeah,
So
exactly. Yeah, yeah.
now there is only one row of box, so there could be multiple rows of boxes as well, and I have to see that how many north arrows and how many down arrows are there to reach the particular point we want to reach.
Exactly.
And
Yeah, for example, if you have something like you have a bigger box, for example, you have this, I'm just adding something extra. Then at each step, when you come to S4, then you have some bigger box of this kind. So you will be having something like now you are coming down to one step, but yeah, there will be some many more. So you have to look at the pattern, because right, yeah, you have to consider all the options, because as you said, there might be a possibility like I stop at S4, but now this box I need to consider, but there could be something extra which I'm looking at. Maybe for example, you have S4. Now there are option of this, there is an option of this. Yeah, there will be more options, so you can again split it into three, but yeah, you can calculate with this also. Mm-hmm. Right. I'm thinking something of this kind, like you come down to this and then calculate. Oh, no, 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 it's fine, fine. Yeah, yeah, yeah. I think you can, what you can do when you have something like that and you reach at S4, when there is S5, there is one possibility. When you reach at S4, now what you can do, you have to go 2 step downwards. So there will be like 2 plus something. Okay, so 2 downward steps. Anyway, you need to consider there is no option of like one step or 3 step. You exactly will come down to 2 steps, because these are the arrows. And now with k, for example, k, choose k, like this should be something according to the box. So for example, as you said, if you have something like this, in this case you will just get 1, k will be 1. When you get something like this, like when you are at S3, then the options, I'm just calculating the options. So 2 steps you will go downward, and what are all the options you can have? You can go like this, you can go like this, or you can yeah, you can go like this. So this will be what? So how many steps are there for this part? This is exactly k. So this will be
I can go like the S path, like is directly one step down, then one step to the east, then one step down, then one step to the west.
one step, sorry, come again. So if I number it, so for example, you are in this box.
Now down,
Yeah.
yeah, so down then east,
Okay, yeah,
then
down then
down, then west.
okay. Yeah, down then, yeah, you can go like this. Yeah, so all the options you need to consider. So what will consider that? This can capture that, right? 2 plus 2, choose 2, because you are going like you are going at this point. And yeah, yeah, actually what is happening, why I'm not able to compare it with the normal thing, because what is happening when you go like this, and then you can come to this step. Okay, and so for example, you want to go at this step, but you are not allowed to go like this. That is the only thing you are not having. So for example, when I'm comparing with this, okay, so in this step, so you are going like this, and then you are going like this, you reach at here, you go like this, and okay, yeah. So the main point is, when you touch the lowest line, the lowest row, then there is only one possibility, because you have to go towards west, right? So that is the main thing which are not allowing you to have multiple options after that. So you just need to touch this line. So this will be exactly 2 plus 2 choose 2. Is that clear? In this case, sorry?
Yes.
Okay. Yeah, so basically you just see the pattern and you will be done. So yeah, 2 steps there, 2 steps there. Just look at the how many steps are there. So yeah, if you have much bigger, if you have like 5 rows like this, then again you consider this box, then this will be 3 plus 2 choose 2. Yeah, so you'll get like this. Okay, so as in your question, now there is no 2 thing, you are just getting, yeah. So here what you are getting, as I said, you have one line when you at S5, you will get a box when you reach at S4, you will get the double box when you reach at S3, uh, and when you reach at S2, so this is the box you will get, right? So 3, so you're getting one extra box. Okay, so because of this, this will be just 1. So if you look at the pattern, this is like this: 1 plus 1 choose 1, 1 plus 2 choose 2, this will be 1 plus 3 choose 3, because options are where, like options are here only on this side, because when you once come downwards, so you have to come down by 1 step, but the option will be here. Okay, so you just need to choose one path. And if you observe, this is nothing like this is exactly this value, because this is 3 choose 1, so you can replace it by 1. So this is the exact this will be 3. So this is something like 1 plus 2 only, this will be 1 plus 3, this will be 1 plus 1. So but never mind. So basically what you can say, the M11 will be summation k is equal to 0 to 3, and you will get 1 plus k choose k. Okay. What other thing they have asked? M12. Okay, so what is M12? So I'll copy again. Yeah, so M12, let's see. Okay, so you have B4 and you have S5. Okay, now you need to consider, now you need to calculate paths from M1 to M2, A1 to B2. So again, we'll look at the pattern now again. So A1 to B2, now if you compare with M11, what is happening? Now same thing, you will go like this, you will go like this, and you will go like this. Not here exactly, you'll just reach here, because there is no option, there is no other option. So whether you reach at B2 or B1, it is the same thing. So this is okay, so 1 is there. So for example, if I write it in that form, so you have 1 plus 0 choose 0. Now you go till A4. Now what you do, you go till A4. Okay, you stop it here. Now A5 condition you have already checked. Now you reach at S4, so this is with S5. Now you check with S4. So will S4 create a problem? Because when you reach at S4, there is this box only which you need to consider, and this does not come into B1. This is not related to B1, so B1 is very far from this box, so it will not create any problem. So whatever you get earlier, you will get the same thing. because you have to consider all the options. So basically this is this and this, two options only. And when you reach it, as I said, when you touch the ground, when you touch this row, last one, then you are done, because there is only one possibility after that. So this is this. Now with S3, so yeah, I'm talking about M12, that is A1 to B2. S3 will be the same. Again you will get the box, the bigger box, this rectangle, this box. So again this is the same thing, because B2 and B1 are still not near. So this is 1 plus 2, choose 2. Now what about S4? So sorry, not S4, S2. Yeah. So when you come to S2, now again you have this box. Still there is no issue, because you need to reach at B2. That is okay, because in this B1 is not coming into the picture. So this will be exactly 1 plus 3, choose 3. Now that the next one could be a concern. So what is S1? So when you so this is when you stop at S2. Now when you stop at S1, when you reach at S1, A1 to S1, then what are the possibilities which are not now with the condition A1 to B2? So when you were having A1 to B1, then you have this path. But now you cannot, if you go till B1, then there is no path between B1 to from B1 to B2. So there is nothing you cannot consider this path. You cannot go downwards. But so this one path is something which you cannot take. So what you can do? So this path is gone. But when you have reached at S1, so you cannot go this, but you can go all the other paths, like you go this and then this. So you have this box. So basically if you observe what we are getting, if you observe that you when you reached at S1, you have to go to S2. So there is no other option, you have to go to S2. And when you go to S2, there is only one box, which is 3, which is the box of 3. So this will be 1 plus 3, choose 3. Is that clear how we got S1 part? So when you go to S1, then you have to go to S2, and then after S2 you have this 3 cross 1 box, or 1 cross 3 if you consider rows. And is that clear? What is the difference with A11? Sorry, M11? Am I audible?
Yes, ma'am.
Yeah. Okay. So
Yeah, so I think also in the case that I said that
Yeah.
if I have more than
one extra box. Yeah.
more extra rows, then also it's kind of same. Like if we
Yeah.
have like two direction to the east and two to the north, to the sorry south, two to the east, two to the south, then also we have total 4C2. I mean 6 paths in total. There will be in that box, in that 2 cross 2 box.
But there will be more. So what will happen when you have one extra box? So for example,
Yeah.
again, so
So within that box there will be 6 paths in total.
6 as in, can you tell me in combination? So what exactly you are saying?
So
Yeah. So when you are trying to
just
yeah.
name one box, one such 2
Yeah,
cross 2
yeah,
box.
exactly. 1 second. So this B3, B2, these are now at this row. B1, B2, B3, B4, B5. Right? Yeah. So yeah, T1, T2L.
Between T1, T2.
Yeah.
Okay.
Yeah.
So
So
let's say I have this S3, S5, B5, B3. This is my 2 cross 2 box. S3 to B5. S3 to
S3,
S5, S5, S3 to S5, S5 to B5.
yeah, S3 to S5. Hello. Yeah.
Right, I am at S3.
Yeah, you are at
I am
S3.
at S3, so I have to I can check. Hello.
Yeah, I can hear you now. So you are at S3. You will go like
Yeah.
this.
So what are my paths? Say? I have to go from S3 to B3, right? I have
Yeah.
to go from S3 to B3. So I can go directly S3 to T3 to B3. That is one path.
Yeah.
Then I can also go the largest one,
Yeah.
S3 to S4, S4 to
Yeah.
S5, S5 to T5, T5 to D5, D5 to D4, D4 to D3. That
Yeah.
is one path.
Exactly.
Then there is one path, this
Yeah.
S3 to S4, S4 to T4, T4 to T3, T3 to B3.
Yeah. So.
That is one path.
Hmm.
Then there is S3 to S4, S4 to S5, S5 to T5, T5 to T4, T4 to T3, T3 to B3. That
Yeah.
is one path.
So exactly, you will get this again. Two steps downwards. You are going 2 steps at this line. You are
Yeah.
going. So
So
you'll get two.
basically, I have four options. Either go 2 step downwards or go 2 step eastward.
Okay. You'll
So
get six actually.
I will get six, four
Yeah,
C2.
yeah, 4C2, exactly, I wrote. Yeah, so what
Yeah,
you do, you just consider like how many paths you can go downwards and how many paths you can go on the right.
on the right, yes.
Yeah, like, yeah, whatever direction you say, yeah,
Yeah.
west and south. Yeah. Okay. Yeah, so you will get this, and where the problem or maybe where the difference will occur. So A1 to B1 we are okay. Now when we are going to A1 to B2, now the problem will be on this path. When you reach to S1, then only there will be a difference, because you cannot go direct this. So when you go direct A1 to S1 to S1 to A1 S1 T1 B1 and B1 to B2, you cannot go. So when you hit the ground, like when you hit the last row, you cannot go on the right. So that is the main thing. So you cannot consider this path when you want to go to A1 to B2. So what is the key? You get to S1, then you go to S2. That is one option, right? What you will do, so when you okay, so when you go A1 to S1, then A1 to after S1 you have two choices. Either you can go to S2 or you can go to T1, and then T1 to T2.
Ma'am, so if I want to go to other points, say not A1 to B1, those things, but A1 to B2, A1 to B3, etc. So what if we do like consider all the possible path in the upper row boxes, and then for the lowest row, I just see how many paths I have in the lowest row. First, we consider recursion on the upper rows.
Okay.
And then for the last row, I see that how many paths I have in the last row.
Okay, I got your point. Yeah, we have to check. So, for example, you are saying you put the recursion on the last box. Okay, right. Uh, okay, yeah, you can do that, because both row, whether you go via row or column, both are fine. So basically, you are saying at this step you will not consider where you will consider do you have to consider more now? Exactly where will you apply recursion on?
So I can like start with A1. So
Hmm.
I can look at how can I go from how many ways I can go from A1 to T1, and also I can look at how many ways I can go from A1 to A1 to T1 and A1 to T2.
Okay.
Uh, then I see that from T1 to B2 and from T2 to B2 individually.
Okay. But
So
there are like two things you are considering no, but
yeah, so
like
the
you have to
point.
apply
So
recursion
for
at
example, you are in your case you are doing like considering from S1, then you are looking at the boxes.
yeah,
So
exactly.
I am looking at the boxes up to before T1, and then
Okay.
I'm looking at T2, then T3, then T4, etc. So
Okay. But you
so
have to
say
apply recursion at this point now. at this point
Yeah.
also, like here also there will be something like you are going at T2 to T1, but yeah, you can consider the ways will be at this level now, like whether you reach at T5. When you reach at T5 there is only one option, like
Yeah.
this, and then when you reach at
This
T4 there will be one box
one box.
again. So you have to consider all the options. So right now I can see this
Yeah.
S1 S2 S3 will at least give one time recursion for me, right? So
Yes.
yeah, but you can try, like there are many ways to calculate things. So yeah, this is definitely one option, so you can try more. But yeah, so for example, the main point I want to let you know that when you come to A1 and then you want to reach at B2, then you
But
have.
the good thing is that see because there is only one box at the last row, so
Mm-hmm.
I only know that at T4 there are two choices. So it's not like I have to compute the two choices. I know that there are two choices. No.
At which
Uh,
level?
at last level like
Acha,
T4,
okay,
if
yeah,
I
yeah, yeah.
compute everything above, then
Mm-hmm.
I know at the last level at T4 I have two choices. Say
Mm-hmm.
at T3 I know that there are
Mm-hmm.
three choices, or maybe whatever at one box there
Mm-hmm.
can be how many. I can yeah, it's like a product of two recursion, like either it's
Mm-hmm.
a division at the middle, like
Yeah,
the
yeah,
entire
yeah.
path divided at the
Mm-hmm.
middle, then recursion on the upper section, and recursion multiplied with recursion on the lower section.
Okay. Yeah, yeah, yeah. I got your point. Yeah, you have the value, then you can see that, because this is something computable. But if you get something more big grid, it's like for example 5 cross 5 or 6 cross 7 something. If you get something big, then you have to come up with some sorted thing. But yeah, this is definitely an option. You can still check like if this gives the exact value or not, same value. Yeah, but yeah, definitely you can try with this TIs. You can apply it at TIs, the options. Yeah, yeah, you can do that definitely.
Okay, ma'am. Okay.
Yeah, try that. If you get in trouble, let me know next time, no problem, or you can email me.
Okay, ma'am.
Okay. Yeah, so yeah, what we are getting, so yeah, as I said, from A1 to B2 you cannot consider this direct step, that has to be removed. Or if you remove this step, and is there any other step you have to remove? There is no other thing you have to remove, so you can just do -1 at this step. Is that okay? You just do -1, because there is one path you need to remove compared to M11. So when you considered M11, then when you reached at S1, then you have considered this box, this full box. So in this box, A1 to B1 has been considered. But when you have been asked about A1 to B2, then you have to remove this part, because if you reach at B1, then you cannot go to B2. But there is no other path which need to be removed, because when you reach at S1, this is one option, and the other options are going to S2, and when you reach at S2, there is always an option to go to B2. So what I'm saying, when you calculate this M12, what you will do at S1 to S2. So there are two things I can do. Either I can write this, or I can write it like 1 plus 4 choose 4, which we have taken, -1. Both are the same thing, so you can think of in any way. So as I said, there are many ways, as you were suggesting also, like you can try with T1, T2, T3. Yeah, there are many ways to calculate, so just try it out. If you find it easier, then you do that definitely. Okay, so M12 will be exactly this. So this is the sum. K is equal to 0 to 4, 1 plus k, choose k, -1. So I've just removed -1. Or other way is like you just write k is equal to 1 to 4, because when you put k is equal to 0, this is 1 plus 0, choose 0, which is 1. So you'll just get 1 only when you put k is equal to 1. So this is exactly, so simplify, you can actually write it like this. Okay, so like this you can consider and try with a2 to b2. That will help you, like with a2 to b2, then this last term has to be removed. Okay, 1 second, I wrote it till this is 0 box, this is 1 box, 2 box, 3 box, 4 box. It should be till 4. Okay, this is still 4 because when you there is an option of s1 also. When you reach at s1, you have 4 box thing, like 4 grid. Okay, is that clear?
Yes, ma'am.
Okay, so yeah, these are the ways to so m11 is this, m12 is this, m24, I'll quickly calculate what is m24. So you are at a2. So what I'm saying, you will have to remove the last one at each step. When you come to a2, then you cannot have this s1 box, because you cannot go to s1. If you go to s1, you cannot reach at sorry at, right at this level this is okay. But when you want to write a2 to b3, then let's see what do we have. When you start at a2, then you can go to a3, and so again I'll do the same thing, this part, and coming to b3. So you have this 1 plus 0, choose 0, plus is that clear, or should I make another? Yeah, so what I want to say, you are starting at you are calculating m24. So what is m24? You start at a2 and you have to reach at a4. Okay, so you can go like this, which is one possibility, which is 1 plus 0, choose 0. So you are coming from s5. Okay, this is with s5. With s4 it is again okay, you go with like this. With s3, now s3 is a okay, with s3 mean you come to this place. Now you need to go to b4. Okay, now what are the options? When you come down to s3, then you cannot go to b4 for sure, because when you because if you go to b4, you cannot go to you cannot go to b3 so that you can go to b4. That is not a possibility because arrows are reversed. So you come to s3. When you come to s3, then you have to go to s4, because you cannot have this path. So you have to go to this side. When you go to s4, then there is one possibility, like there is this possibility only to reach at b4. Again, when you
Yes.
right, so when you have s3, now you cannot go behind, like you are starting at a3. This is the this sorry oh you are starting at a2. So now what you can do, you can go to s2. Now again, if you go to s2, you cannot go to b2 because b2 does not get you to b4. So again you will go to s3, and when you reach at s3, you have to go to s4 because you need to reach b4. So this will again give 1 plus 1, choose 1. So like this you can actually calculate it. So you will get the sum to be yeah, sum, maybe I'll just write like this only. 1 plus 0, choose 0, plus actually this is 2 plus 2 plus 2, this is 7. So you'll get this value to be m22, m24. Try to generalize for the bigger things, but yeah, this is the way, this is one way, obviously. Yeah, so now let's calculate the determinant which was asked. So these three values was asked. Now let's see what is the determinant. Determinant of m, again you need to consider omega i's. Yeah, you'll get this, and omega I is a path from ai to bi with pairwise non-crossing. So V of omega I, product. Now let's see again how many paths do we have. So yeah, because product is anyway omega wi is going to be 1, so you are just, and this product is again 1 if it exists, if there is big omega, like the whole omega, if there exists one, then there will always be this value is going to be 1, but if it is empty sum, then it is 0. So let's see what do we have with this uh, again. So you start at a1. So is this the cleaner one? Okay, all is messy, but still arrows are, you can see. You start at a1, you go to b1. So a1 to b1, again you cannot okay. So if you go there is one path, or to reach at a1 to b1 you have to cross other bis ais. Okay, so you don't want to do that, because you want non crossing. So a1 to b1 there is one path. Now again, if you are at a2 and you want to reach at b3 b2, then there is one path definitely. But if you choose any other path, either this, then again you have to cross some of the other ai or bi, right? So at each step there is only one path from ai to bi. So this will actually be just one. This is just one. So as I said, determinant is easier to calculate if these things are there. Is that okay?
Yes, ma'am.
Yeah. So yeah, this lemma helps to calculate the determinant without even knowing the values. Obviously there should be a graph for that, but yeah. Okay. Let's move to the next question then. Consider the path matrix M. You have this matrix Mij. Yeah, again, same thing. Okay, now the arrows are similar. No. Now the arrows are like this. The first row is also reversed. Okay. So now what is the big difference? That earlier it was a1 to a2, right? So what I'll do, one thing, I should copy this so that I can use it easily. Yeah. So you have this. Now let's see. Again, you need to, for example, you need to consider A22, M22. So let's calculate what is M22. So what you need to consider, you are at A2, A2 to B2. Okay, let's see how many paths do we have. So again, you cannot, now you are moving towards this, not rightwards. You are actually going to the left, and again the all paths have the weight 1. Okay, all h. So you are at a2. Now you can go to a1 and you come down to this and you can go to this. So there is this one path. So what you are actually yeah, you have only this option. Now you just consider from the left side. So you have this, or again I can consider, as we considered this t1 t2 as you asked, you can use it here. So you have this t1 t2 t3 and t4. So you are at a2 now. Now again I'll do the same thing which I did earlier. So you take s2, sorry, yeah, either you can go to s1. Yeah, there is one thing. Now when you reach at s1, then there is only one option. No, 1 second, there is no cycle, right? Yeah, there is no cycle, but the main thing is, if you go downwards, yeah, you cannot go right.
I cannot go to the right.
Yeah.
So A2 to B2 will only be like the straight thing. A2 to S2,
Yeah,
S2 to T2, T2 to V2.
exactly. Yeah, there is no option to go to the right. Yeah, so you can just see, yeah, there is this path. You have, if you go like this, you cannot come like this. Yeah, nice. Yeah, so you have you start at A2, you go to S2, you go to T2, and you go to B2. So you get this. This will be M22 is just 1. There is this only possibility. Now let's see 4 comma 4. So you are at A4 and you are
A4 to B4 also same thing.
yeah, exactly. I should reverse something because this looks,
But
yeah,
A2 to
A,
E1, for example,
yeah,
that will be more
yeah,
options. There will be
exactly.
more options there.
Yeah, so let's
A3 to
change the
B2,
question.
etc.
Yeah, exactly. Let's change the question. Little bit interesting at least. So, for example, you consider A1 to B4 is interesting? No. You consider A1 to A2 maybe. Okay, so you have A1 to yeah. So you have A1 to A2. At this level you need to reach. Now again you cannot go rightwards, but if you come from left, uh, oh, there is again one. Even not one. Okay. Which one you said? Okay, which one is interesting? I'm looking at it. So this is this. You can come to B1. Now let's say 1 1 only. So you start at 1. Oh, right. Okay. So you do 4 comma 1. That might be interesting. Okay, 4 comma 1. So you are at A4. You need to come at B1. Yeah, exactly as you said. So you can come. Okay, there are again many options. What you can do? You can go to S4. Right. Either you can go to S4, or you can go to S3, S2, and S1. Okay, let's see if there is any box interesting. So when you come to S4, then you have this 3 cross 3 box. Yeah, is that clear? 3 cross 2 box. Hello. Yeah. Sorry. I was just asking because I thought it is disconnected. So you have A4 to B1. You want to come to B1, and now you want to calculate this. So what is the possibility? Again, if you come to S4, A4 to S4. If you come to S4, then you have this box. Now when you go, there is an option of going downwards, which is 2 steps, and to the left there are 3 steps. So this is like 2 plus 3.
Yeah.
2 plus 3, choose 3, right?
Yeah. But I want to go from A4 to B1, right? So I can take the entire box at the same time from A4 itself, not from S4. Starting with A4 itself, I have 3 arrows to the west side and 3 arrows to the south, right? So there is like
Yeah,
3 plus 3, 6, choose 3
yeah, very
in
good.
total.
Yeah, very good. Yeah, this is all you can have. Yeah, nice. Yeah, very good. So you can actually directly calculate. Yeah. Yes, you can directly calculate A4 to B1, which is just all the paths. Nice. Yeah, paths maybe. Yeah, you can do that. And if, for example, yeah, you can, so you can calculate now, right? So if you want to, for example, if you just need to reach B2, you can just consider this box. Yeah. Yeah, so yeah, this is easy. So you just consider all the boxes which you are getting, and then you are done. Yeah, nice. Is that clear, both of you?
Yes, ma'am.
Yeah. Okay. Yeah, nice, Shantini. Okay. Sorry.
It means which one we have to choose, maximum one or minimum? Here,
Maximum means.
here we can go A4 to S4,
Hmm.
and then
Yeah, actually, as Shayantini said, what you can do, you need to go from A4 to B1, right? So you consider the entire box, because what you are allowed to go towards this, come down to this. Like you are allowed to go left and downwards, so you can directly calculate this A4 to B1. So you are allowed to go 3 steps downward, 3 steps to the left. So you this will be just 3 plus 3, choose 3. So you don't whether if you even consider this now, S1, S2, S3 and S4, you will actually get 2 plus 3, choose 3. At second step you will get 3 plus 2 plus 2, choose 2. Next step you will get 2 plus 1, choose 1. And at the last step you will get 2 plus uh, yeah, 0, choose 2. So again this sum, if you sum it up, you'll so it's just the combination. So binomial, this will be actually equal to 3 plus 3, choose 3. You can get it like so you have 5, choose 3 plus 4, choose 2. So and this is what was the formula was, if I remember correctly, this is something like um, so 5, choose 3, this will be equal to 5 uh, yeah, sorry, I'm just trying to get the formula. So this is so n plus 1, yeah, choose r is equal, sorry, r plus 1 is actually n choose r plus n choose r plus 1. Is that the formula, right?
I think it is n choose r plus n plus 1 choose r.
N choose r plus n plus 1 choose r. Okay. I don't remember it exactly. Okay, but yeah, even okay, you said n plus 1 choose r.
Yes. I just check it once with something.
Uh, okay, okay. But anyway, that will not be of much help here. So for example, I'll just calculate it. This will be 1, this will be 3, this will be 6, this will be 5 into 4 by 6, sorry, 5 into 4 3 by 3 2, for example. Yeah, 10, right? So you'll get 620, right? And now if you calculate 6, choose 3, what will you get? 654 by 6, right? So yeah, so these are same. I know even so you can check it, you can actually prove it, but I'm not remembering exactly. Okay, but this is just combinatorics, this is just permutation combination formula, so you can check it. Actually you can use the basic formula also, like n factorial or something. So is that okay? So whether you come with S3, S4, S2, S1, or whether you consider the whole thing, you will definitely get it. So exactly as you were earlier saying, Shantini, you can go sorry, you can go to T3, T2, T1, and if you are getting two combinations, now if you are taking you are getting two recursions, then if you combine those recursions, you can actually have something related to S3, S2 also. So these are all same, it's just how you are calculating it. Okay. Yeah. Okay. So Is that clear, Mahalakshmi?
Yes, ma'am.
Okay, so this is, yeah, M2. So the interesting one is actually 4 to 1. So we calculated this. Now this summation also you can actually calculate if you have all the values. Now let's see what is the determinant of M. So determinant of M, again you will, so you need to consider the paths which are from A1 to B1, like A2 to B2, A3 to B3 and A4 to B4. So again I think you will have only one, because if so the interesting is A4 to B4. Oh, actually this is only one. Yeah, you cannot go to right, so you cannot come like this. So there is only one possibility. So even, yeah, actually M11 MII is actually 1 for all I, because there is only one possibility. Because if you go left or right, or right anyway you cannot go, if you go to left at this step, then you have to come back to B2 or B3, then you have to go right, but that is not an like you does not have that arrow. So M11 actually, M11, M22, M33 and M44 is actually 1. So there is only one path which is also non-crossing, pairwise non-crossing. So this is just 1. Determinant you will get 1 only. So because there is only one path, W1 to Wn, and all the weights are 1. Is that okay? Okay. Okay. So you can deal with such questions hopefully now. Okay. So let's move to the other part. So it's symmetric function. Symmetric functions is actually basically the questions are related to symmetric and skew-symmetric matrix. So I kept something like that. So any square matrix can be expressed as a sum of symmetric and skew-symmetric matrix. So basically what is symmetric matrix? Just to recall.
A transpose equal to A.
Yeah, exactly. A transpose is equal to A. So A transpose is just you change rows will become column and column will become rows. So what you are doing, Mij entry will be in A transpose. So A transpose is Mji. Yeah, the same entry. Yeah, Mgi and I is equal to 1. So this might be confusing, but what you are doing, this will be M21. So it was in A transpose. A transpose you have M21 and just your rows and columns have been switched. Okay, so I and j is equal to 1 to 4. Okay, so yeah, A transpose is equal, whenever A transpose is equal to A, for example, if you have 1 1 1, actually diagonal entries have to be same, because when you transpose it, you can have anything, for on the diagonal you can have anything, it doesn't matter, but on this and this has to be the same value, because this is M12, this is M12 and this is M21. So this have to be the same value, because we are saying A transpose is same as A, so all the entries should be same. So for example, M11, M12, M13.
First row and first column same.
Yeah, first row has to be the same as this column, because we are switching. So yeah, exactly. So yeah, so for example, we can consider something like maybe 3 and here 3, 5 and 5, 4 and 4. Okay, this is one of the example. For skew symmetric, A transpose should be equal to minus A. So that means you take so yeah, again now what you need, so on the diagonal what can you say? So what you want when you compare it, so as I was earlier writing, so I'm just considering 3 cross 3, or maybe let's consider 2 cross 2. So you have M11, M12, sorry, M22, and you have M21, and you have M12, right? Now when you transpose it, so this is your A, and now A transpose is M11, M12, and this is M21, M22. So what we are saying M11 should be equal to, so you have been asked A transpose whether A transpose is equal to A or not, right? So A transpose is equal to minus A means all the entries, so M11 should be equal to minus M11, M12 is equal to minus maybe M21. So I'm writing this entry of A transpose, and this should be minus of this entry of A, that is M12. Now again this is the same thing, A12 should be equal to minus of M21, and M22 is equal to minus of M22. So as you can see in this part, if you take it to the right side, this is 2M11, this has to be 0. Now okay, if you know fields, you can say that we are in integers, like integers, entries are integers. You are not in the characteristic field, sorry, you are not with field of characteristic 2. So if you know that, that's okay, otherwise you can just think of the entries are integers. Even there also it might be okay, but yeah, we can just consider integers right now. So you have 2M11, or maybe real numbers if you would like. Yeah, so 2M1 is equal to 0, that means M11 is equal to 0. Similarly, from this you'll get M22 is equal to 0. And from this, is just say if this is 3, then they should be minus 3. So it's like we are saying the diagonal entry should be 0. How many are there? We don't care, but and if you have something minus A, then it should be A. This part should be like minus of each other. Okay, so this is skew symmetric. Now it has been asked, any square matrix can be expressed as a sum of symmetric and skew symmetric matrices. Do you know, or
Yeah, so I can take A plus A transpose by 2, or A plus A transpose itself.
yeah, exactly.
And A minus A transpose is skew symmetric.
Yeah, skew symmetric.
So I can take half of half, equal to A.
Yeah, exactly. So this is the answer. This is very famous question also. So yeah, the main thing is this is A plus A transpose is symmetric. How can you check that? Because A plus A transpose, if you take the transpose of it, now with transpose it works well with addition. That is very easy to see even. So this is just this. So these are square matrices. So A and A transpose is this, and now you'll get A transpose plus A transpose of transpose, and that is equal to just A. So this is so this implies, so what did we get? A plus A transpose, if you transpose it, you will get the same thing. So this implies A plus A transpose is symmetric. And if you consider A plus A minus A transpose, then you take the transpose, what will you get? A transpose minus A. So exactly you can see there is a minus coming into picture, like you can just pull it out. So you'll get this matrix, the transpose of this matrix is minus of the matrix. So this implies A minus A transpose is skew symmetric. Okay, so yeah, the key idea is you write A plus A transpose. You just add this and subtract this. Then you got 2A, so you divide by half, and you want to write it as the sum, just the sum in the, so you can write it like this, because any multiple of a symmetric matrix is also symmetric, so that's okay. So this is your A, and yeah, we are in real numbers, so half makes sense. Okay, yeah, great. So you can write it
Ma'am,
as,
there
yeah.
was a question.
Mm-hmm. Yeah, there is one more
Yeah,
question I
there was
want
a
to
question.
discuss.
Uh,
Yeah.
Determinant of I plus A minus A transpose is always non-zero or not for a real matrix.
Uh, I plus.
Determinant I plus A minus A transpose.
Mm-hmm.
This entire thing. This
Yeah.
determinant is non-zero or not for all A real A.
Yeah, this is in the assignment, right? Yeah.
Yeah.
Okay, think about it. Yeah, you just think like, because note that A minus A transpose is skew symmetric. Can you come up with something? Okay, I'll go to the next question that might help you. Or okay. So
Okay.
yeah, determinant of the following matrix A is, so obviously I don't want you to calculate this determinant, but can you tell me, yeah, can you tell anything about the determinant without actually calculating it? What can you observe in this determinant?
So
Sorry, matrix. Yeah.
okay, so this is the
Yeah, diagonal is 0.
skew symmetric, right?
Yeah, this is a skew symmetric matrix.
This is skew symmetric matrix.
Yeah.
So diagonal is 0.
Hmm.
Zero. Determinant of space.
Uh,
Yeah, actually, yeah, I think you said determinant is 0, right? So basically, A is skew symmetric. So this implies what will happen, A transpose will be equal to minus A. Now again I said with the entries integer. Now if you calculate the determinant, so determinant should be equal to, sorry, yeah, yes, that's okay. So A transpose is equal to
okay.
minus A.
Determinant of A transpose is determinant of minus A.
Yeah.
So that should be minus 1 to the power 5 determinant of A. And that is equal to minus determinant of A. So determinant of A transpose is also determinant of A. So determinant of A equal to minus determinant of A.
Yeah.
That means determinant of A equal to 0.
Yeah, exactly. So you have determinant of minus is same as this. So actually this is determinant of A. This is equal to determinant of A. And you'll get 2 determinant of A. That will be 0. So determinant of A will be 0 because you are not in a um, characteristic 2 field. So if you know field, then you will know, because 2 will be 0 in characteristic 2, so that then you cannot say like this. So determinant of A is 0.